Hi folks, my name is Balyuk, and today I'm going to introduce you on how to run your code in the cloud. I'm gonna give you a generic introduction to what the cloud is, how it works, different services the clouds offer, and different service vendors available out there. And after we go through the basics, we're gonna actually implement a small application. We are going to configure it in Azure Cloud, deploy our code, um, and run it all in the cloud, completely serverless. So let's deep dive into this. You probably all know a little bit about the cloud, about the basics, what it does. It's basically a service provider which offers computing services. In the past, companies had to run traditional on-premises IT, which required, worrying about everything from a data center to figure out how to run networking, uh, run wires through the ceilings, managing physical servers, all the software associated with operating systems and the servers and the networks, managing their own databases. Basically, when you run traditional on-prem IT, you're responsible for everything. You need to have people administering and managing everything. Another option is running a colocation, and that is when you don't worry about data warehouse, you just put your servers into somebody else's data warehouse and just plug in networking, and you're responsible for your own servers. So if disk fails, if CPU fails, you have to take care of this. Then companies evolved into other services like a hosting, where you don't have to worry about the servers. You're now not responsible for the servers. You only worry about running actual operating system, virtualization software, and managing software stack on top of it. Um, Nowadays, clouds, whether it's Azure or AWS or Google Cloud or IBM Cloud, they offer services which simplify this even further, and they focus on three main um, types of solutions, which is infrastructure as a service. Infrastructure as a service is where um, organizations and IT departments don't have to worry about the data center, network, nor servers, nor even virtualization. They just get virtual machines running in within the cloud environment, and they interact with them. They are responsible for patching software, patching operating systems, installing and configuring application software. It's still all of their responsibility. A step further is platform as a service, and this is where the cloud providers, they actually take care of the operating system management and of the core software which runs on it. For example, MySQL or SQL Server can be offered as a platform as a service, and the users of those services don't have to worry about installing MySQL, updating MySQL, patching it. They only use it as a service. They basically just connect to it, spin up their databases, and enjoy it. Same applies to some of the container services and web application hosting options. Now, software as a service is the last example here, and this is more centered around consumers. Think about it as Gmail. This is consumer oriented. You sign up for some web application service, you log in into it, and you are completely independent, do whatever you need within that software stack. So again, just to recap, in the past, before the cloud, um, there was a big upfront cost in order to run traditional IT on premises. Co-locations were an option, but the organization still had to worry about physical servers, networking, deal with all the hardware failures and management of it. Um, Hosted solutions all simplified it even further, where people didn't have to worry about the servers. They just rented a space within a server, and then they were able to achieve what they wanted to. But nowadays, clouds primarily concentrate on infrastructure as a service, and a platform as a service. SaaS are some of the other solutions which provide consumer services. Here is a different look at SaaS, PaaS, and IaaS in the shape of a pyramid. And a pyramid represents the amount of control IT administrator or a user of those services has. For example, when you talk about software as a service solutions, that's your Salesforce, your Gmail, really, I mean, Facebook, Twitter, Instagram, all of them fall into this software as a service where they do offer marketing solutions and so on. But you can also think of Google Docs, Office 365, and some other similar services as consumer-centered, end-user-centered solutions. Platform as a service is example where you don't have to worry about running the actual servers, applications configured in a certain way to host the software, and software developers can really utilize and just using their code and deploy their code in the cloud without having to worry about how to configure an operating system to run in a certain way and how to configure certain versions of software runtimes and all the dependencies associated with it. Now, infrastructure as a service is a step further, and this is centered around IT administrators. In a way, this is like having a virtual machines and then just letting administrators manage those virtual machines, in which case, IT organizations would still be responsible for patching software, for dealing with some software incompatibilities and so on. In our hands-on experiments later today, we're going to concentrate on platform as a service solutions, and you will see how easy it is to run databases, queues, and application in completely serverless environment. Today, there is a number of different cloud service providers. The three biggest ones are definitely Azure, AWS, and Google Cloud. IBM Cloud is also there. There's some other players in the market, but they're not as big and don't offer as many competitive services as the main ones. So again, Azure Cloud, AWS, and Google Cloud are the primary leaders. And today we're gonna take a closer look at Azure and explore some of the features it offers. Here is a comparison matrix. It highlights different services, different products really available out there in open source world or proprietary world, and how they map to the cloud provider offerings. For example, platform as a service, Elastic Beanstalk is AWS version of allowing to run Docker containers in a cloud. Microsoft Azure has different cloud services, application services, which allow to do the equivalent, and Google Platform has App Engine. All of them have competitive features. All of them offer very similar features. Some have slight advantages over the others, but overall, everything is very similar. A lot of organizations are, a bit concerned about vendor lock-in. So they're trying to utilize more generic services which don't, restrict them to only going with AWS, and they keep that option open as much as possible in order to take advantage of competitive pricing between the three different vendors. When organizations spend a few $1,000s here and there, it's not really a problem, but large organizations spend tens of millions of dollars for hosting and for running the cloud environments. And the cloud environments want everyone to learn their cool features which they have to offer. I mean, they're so excited about all of their stuff, and they want the students, they want researchers, and they want business professionals to be able to educate themselves on the cloud solutions which they offer, and they want them to for you to fall in love with what they offer. Because if you fall in love with what they offer, if they give you all the necessary stuff that makes you successful there, then obviously it's a no-brainer that that you and business will pick those solutions. Here is a list of completely free cloud training programs available on the web. They're available directly from these cloud providers. Amazon AWS has a whole Educate program, which goes in depth and educates students on how AWS works, what it does. AWS offers a free tier services, which is free to a certain extent for a duration of a year. And a lot of low-level usage is free, and you can play with it, utilize it. Microsoft Azure is a little bit different. They don't really give you a free tier usage, but they do give $100 credit for students, and all of their services have certain level of free, as long as you don't overutilize them. But on the other hand, Azure has by far superior learning material and certification programs, which are very intuitive and are extremely in-depth. Google Cloud doesn't have as much marketing material around their cloud, but a lot of generic information can be found in the following links. Let's take a quick look at Azure learning materials. As you can see on this site, you can filter by different roles the areas that you're interested in. For example, if you're a solutions architect, you might want to explore this path. If you're a student, well, they start with the basics. They even teach different programming languages and different features. That's actually not what we want. We want to focus on a developer in the cloud. And right here, you have a 4-hour tutorial which guides you step by step on how to deploy a web application in Azure services. The lesson is really broken down into different modules, and as you walk through those modules, they actually have hands-on experiments which you can utilize. Extremely helpful, extremely in-depth, very easy to follow, lots of great information. Amazon AWS Educate, on the other hand, has a little bit different approach. It's not as open up front with all the stuff they have, but you can sign up. You can join AWS Educate, and you can sign up as a student, educator, institution, and they give very tailored, basically AWS Academy there. So definitely explore these links, explore these resources, test out different clouds, see which ones you like better. That really covers all of our cloud introduction recap before we really jump into the tutorial, into the hands-on experiment. But here's a quick recap of other DevOps practices which we discussed earlier. The end-to-end process, 1,000-foot view in modern technology, is really automated end-to-end. There is no the manual processes are kept to a minimum or only in early stages in experimentation. But as the product, as the organization matures, you want to be able to move very, very quickly and you don't want to repeat the mistakes of the past. So the process is automated end to end. Everything is developed as code. Code is in repository, a build server like Jenkins or GitHub or Azure Devops. There are many different ones. They monitor the repository. As soon as they see the changes, they start building and testing applications. At some point, they will publish a container image in container registry, which is a repository of containers with the software configured within them, and then the deployment process automatically pushes the applications to the test environments, and after certification and approvals, it can be released to production. For example, companies like Netflix and Amazon, those companies are by far the leaders in how these processes are done, and they manage to push hundreds and thousands of releases per day. On the other hand, some other companies are lagging a bit behind and barely able to do one release a month or even like one release a quarter. And that just kind of helps you contrast how quick some of the leaders are, the companies which are leaders in today's software, how quick they move. And it's very important to keep up and be quick in this business. So the modern must-haves are definitely version control. You cannot survive without version control. Maybe in some small, tiny project, maybe tiny prototype, it's okay, but it's a must-have practice to have version control. CI/CD pipelines are definitely a must. They enable repetitive testing, they enable repetitive builds, test deploys. They remove the manual processes which are associated with things, and over time they get tuned, they get faster, they get better, and once the processes are repeatable, you can build on top of them and you can make them better. Automation systems and monitoring systems are absolute must, because they help you keep an eye on the system health. They help you understand what is happening. Is the software getting better? Is software getting worse? And as we're moving away from the era of configuring a server, configuring the network on the server, and managing the hardware, nowadays everything runs as code, everything is repeatable, and everything is automated. That is really the new cloud paradigm. Not really new, but that's, a lot of companies are still trying to catch up to this. And once this process is followed, once this repetitive cycle starts rolling, it just starts going faster and faster and faster. And the more automation, the more unit tests, the more optimized the deploys are, the quicker the companies can move, the faster they can release the features to their customers and survive in this competitive market. It's probably enough of talking. Let's deep dive into our live demo. There is, what could possibly go wrong with the live demo? We will focus on a few things. First, I will walk you through a very basic REST API project written in Node.js. We will run the project locally, kind of like we will be the developer. We will contribute some code changes to it, do some minor changes. Besides running it locally, we will also containerize it and run it in a Docker container locally with some dependencies. Then we're going to configure a code repository in GitHub and push our code base to GitHub. This will allow us to keep a code in a central place and even set up a connection between Azure and GitHub in order to keep deploying the code from the repository. We are going to interact with Azure Portal, we're going to use UI tools, not automation tools for configuring environments automatically. I'm going to show you the simplest ways of doing it. Then we'll try to integrate some additional services and redeploy our application. If we've done the previous two steps properly, this will take absolutely no time. It will simply be software changes, and the redeployment will be push of a button, more or less. Here's our demo application that we're going to create. We're going to use Node.js for creating REST API. REST API is going to talk to MongoDB underneath, and we're going to use MongoDB as our database for storing messages. And we're going to utilize Docker for containerizing the application. Docker will allow us to wrap the Node.js dependencies, Mongo dependencies, and run them within a container. This way, when different developers work on it, they don't have to worry about setting up their environments in a specific way. And in production, the deployment of Docker is extremely simple. We're going to utilize Azure App Services, which are tuned for running containers. So deploying a container within App Services is extremely easy task. The user will interact with REST API. When the user interacts with REST API, it is going to talk to a Cosmos DB, which is Azure's implementation of big data storage. It is MongoDB compatible, so it is not using MongoDB underneath, but it is MongoDB driver compatible. It also supports Cassandra, Bigtable, and quite a few other driver APIs. This is going to be our first phase. First deployment will be REST API and Cosmos DB. After we implement this, we will extend our REST API to write a message to a queue, which will be picked up by Azure function and will be sent out in an email using SendGrid service, which is one of the Twilio services. Surprisingly, Azure has no mail support whatsoever, and it relies on the third-party solutions for this. And we are going to utilize application. We're going to integrate application insights into our REST API, and we will monitor the performance of our application using this tool. So if we look at the previous slides, the key things are, version control. We build, we test, we deploy, automation test, deploy to production, and then measure and validate, right? So we're not focusing on unit testing here, and we're gonna have some tests, but not end-to-end code coverage level tests. But in here, we will go from having a code to deploying code, to having code in repository, to building a container, deploying a container. The whole setup will run completely serverless, and we're going to be collecting metrics and monitoring the metrics in our application insights. So this is really representative use case of features which have to be used in the real world. So let's deep dive on the code now. Okay, so we have our Visual Studio Code here. We have Docker Desktop running, which we can interact with. And one more piece of software we're going to use is called Mongo Compass, which is basically a database explorer from MongoDB. We can connect to any database and explore what's happening there. So first we're going to look at, we're going to go a quick walk through the code. Obviously, we're not going to be writing the code here, otherwise it would have taken quite a bit more time. I'll explain a quick structure. The REST API code is located in Web API directory. It is Node application and it has package JSON dependencies. We're going to use three components here, three dependencies, which is that environment, which allows us to read configuration files. Express, which is Node.js web server, and Mongoose, which is a Node.js driver for MongoDB driver for Node.js, implementation of the driver. And we have our main file, which is called server.js. All the file does, it reads the .environment configs on the first step because we need to understand what are our configurations. We don't want to hard code them anywhere in the code. And you can see that here we have environment file, which specifies what port we'll listen to and what connection string will be used. In general, it's a bad practice to commit any kind of secrets, especially if they are for shared environments or production environments. That's complete no-no. But if this is local development, local host endpoint with generic password, it's not a biggie. But it's still bad practice. So what our code does, it brings in few dependencies, initializes a web server and configures the path. If we hit the application on the root, it's just going to return us a generic message, a timestamp, and the host name indicating what server it's running on, just to help us debug. Then we have, we're going to implement basically like notification message API. And when we hit /messages URL via HTTP GET, we're going to retrieve all the messages from MongoDB and return them to the user in a JSON format. Now, this is extremely very simplistic application. It doesn't have implementation for various errors. It doesn't have validation for injections, security, no authentication. This is just for demonstration purposes, just to be clear. Messages API also has a post request, which allows us to capture a JSON payload from the user and save the new message to the database and return the response to the user. Then we have few methods specific to interacting with the message. We can retrieve a single message using the ID. We can put or update a message. Put by convention is used to update. Delete method is used to delete it. Now these methods correspond to HTTP methods, HTTP protocol methods, which are post, get, delete, put, patch. So this is just express library implementation of intercepting those from HTTP message. And the application will listen on the port configured or the default port of 3000, and we have some debug information. Now, important thing is our message model. In here we have a strict structure defined, which is, created at will always be a date. We will have recipient email, recipient name, subject, and message. So not very detailed, but good enough for the purpose of the demo. And we do have a Mongo service, basically, which we initialize from a configuration. It's coming from a config again. And we connect to it, we catch in case if there is an exception, and we export all the models for a server to use. So this is very basic structure. It's not extremely detailed, not well refactored. Normally MVC applications, REST applications follow a specific structure. This is, again, I try to keep it simple so it's easy to follow, easy to understand, not too much jumping around. All right, then if we look at our Docker, you will see we have nothing running here. So before we start, we want to have a database or something to interact. If you look at the README file, there are references to different Docker containers, which we are going to be using for development and testing. And here is a Hindi script, which I created just to help execute and spin up MongoDB running on a local environment on a default port with Mongo admin and secret password, which is again not very secret password, not very good password, but just used for the demo. Now, if I open, you can see that, oops, you can see that it returned me a container identifier. And if I look at Docker PS, Docker processes, you can see that I have one container running. Also, if I take a look at Docker desktop, I do have a new node appear here, a new Docker process running, and I can actually look at the logs, see what it outputs, see what is happening there. Now, just all we really care about is that it is running on localhost and it exposes a port, because we can now connect to it. We can simply click fill out connection locally, localhost, specify a port, use authentication. If you recall, we used Mongo admin and secret. So Mongo admin and secret. And we can click connect. And ta-da, we just connected to the Mongo database. We don't have anything here yet. Application will automatically create the necessary resources using the schema, or if we wanted to, we can click create and we can create new database, new collection, and you can see that it appears here. Opening a collection, we can then import data, for example, and the code contains in Web API. In Web API, there is a folder called data, and it contains some messages that we can import. And you can see it displays now JSON objects inside of our test collection. All right, so that is that. So now we have the service running. And if we look at our environment config, you will see that the connection string points to MongoDB, Mongo admin secret, local IP, local port, messages collection. So messages collection doesn't yet exist. As soon as we start up application, it should create it. So we're gonna do just that. We're going to say npm. First we have to do npm install to install the dependencies, which in my case they're already installed. After we do that, we also are using a nodemon, which is one of the development modules. It allows us to change code and it will recompile and restart application automatically. So we'll just run nodemon. And the application will start up. You can see that it ran Node.js, server.js, and application responded with the database connection string, which is again not a good practice to output it in a console or anywhere really, and the port that the application listens on. If we pull up the application on port 3001, here's our Chrome browser. If we pull up the application on port 3001, you will see that we have application responding with the host name, with the timestamp. When I refresh, the timestamp changes. If I change URL to /messages, it returns what I have in the database, which at the moment is nothing. So what we're gonna do is we're gonna jump back here and we want to populate the data really. So we're going to reconnect real quick to our environment. Mongo does not automatically create the collection. And what we want to do is we want to create the database and collection manually. So right here is our collection. Right there is our data. We're going to import the same file here. Import. At this point, we have 3 records, and if we refresh, you can see that these 3 records are now being retrieved. So awesome. The application runs on a local environment, and we're able to, populate the data. We can also edit the data. For example, here's message, and we will say edited inside of Compass. We're going to update the record, and if we refresh here, this message should change. Yep, right here you can see that it changed instantly. So there are other APIs which we didn't touch yet. You can see that /messages was the one that we just invoked a few times. We didn't post anything to it. We didn't try editing any message, and we will do it in the next step once we compile the Docker container. But you can see that locally the environment is running. You can see it's running on port 3001. If we change an environment config, let's say we change it to 3002, and we start up the environment, it will respect the new configuration, and it will start up on a port 3002, right here, 3002. So awesome. And just so you know, if we refresh, this will probably give me an error. Well, not probably, it will give me an error, but 3002 now returns a response. 3001 says there is nothing listening behind it. All right, now let's take a look at the next step when we compile a Docker container and run our environment in a Docker. Right now you can see that I only have one container running in the Docker desktop, which is MongoDB messages. This is the test database, test Mongo container we spun up a few minutes ago. We don't really care about it anymore. This is more of just used for local development approach. The test we're going to do now is we're going to spin up a whole Docker environment with all the dependencies self-contained. And for Docker, you'll see that there are 3 files really, which I have in the project, which make Docker possible. First file is docker ignore. It's very similar to git ignore. It basically excludes this specific files and directories from ever being copied inside of a Docker container. Think of Docker container as an ISO, as you're burning a CD. If you remember those days when you had to burn a CD and put files on them. Docker ignore will prevent files from ever making it to the disk. Docker file specifies how to build our application. And what Docker file tells us is we're going to use a base image of Node.js 14, which is the latest long-term supported image. We're going to specify a directory that we are going to work in. It can really be anything we want. We just want to use some industry standards. We're going to copy package JSON and install the dependencies. This is a specific Node.js dependency management, nothing special. And we're going to copy every single file into the container. This is not ideal, but this is the quickest way to achieve this. And then we're going to copy a special environment_docker file as the .environment. So we're basically not using our local development environment config. We're using special Docker environment config. Now, if you want to compare them, come on, compare. All right, there it is. If we want to compare them, you will notice that the only difference between the settings are, well, the port, which we modified, that was unintentional. And the other thing is in a connection string, you will notice that instead of connecting to a local host, 127.0.0.1, we're connecting to a host named Mongo. And that's because in Docker, it will make sense once we look at the next step. The next step is Docker Compose. This is our file which ties it all together. It tells us that we're going to spin up a container called API, and it's going to use a container name of FAU demo API. And it's going to build it in a current directory where the Docker file is located. And it's going to run on a port 80 on operating system, while internally it is going to use a different port. And Mongo is going to be, we're going to use an image Mongo, and it's going to be called as a Mongo container. This is how the environment is able to reference this Mongo host. If we wanted to change it to Mongo-host, we would specify it here, but then we would need to modify our container, our config, to specify this host. So this is how basically container names and one container can access the other container while because they're within the same network. So those are 3 magic files which make it all possible. After we do this, all we have to do is say docker compose D for running it in a detached mode as a daemon mode. Docker compose up, detached, and build. And you'll see that first the containers will be built. The containers are building, and you'll see that as soon as they're built, now I'm not seeing a single node here. I'm seeing actually a collection of containers that if I expand, first I see FAU container, our test application, and the other container I see is web API underscore Mongo underscore 1, which is the name of this specific container here. So you can see that the whole environment got spun up. In this case, I have 2 containers. Depending on the size of the application, it might have Redis cache, it might have MySQL, it might have RabbitMQ or some other queuing systems. So it can be as simple or as complex as you like. Some of the applications I worked on had as many as a dozen different services within them, which had to interact with one another. All right, so our application spun up on a port 80. We can click the container in Docker Desktop, and we can see the logs. We can see that the connection string specifies the Mongo path, and the application runs internally on internal port 301, but it is exposed on port 80 at the operating system level, and you can see the port 80 over here in the image. So I no longer have 3301, 3302 running. This will simply time out. But if I do localhost port 80, no need to specify port 80, but you'll see that the application now returns a response, and the host, it's not very descriptive. It is a little bit more cryptic. But if we look, we can probably fish it out, that name somewhere from within the container. Messages. And if I return messages, you will see that there is nothing there because our collection is empty. What I'm going to show you now is I have a small Postman application. Postman is a tool used for REST API testing. It is free, it is extremely powerful, and I've pre-configured the URLs here, and I pre-configured tests, where my tests are simply validating for a response code of 200 on specific tests. If the response code is 200, everything will pass. So you see, if I run get messages, I have nothing. But I do have an API coded that creates a post request to / messages, and it has certain amount of data, certain predefined data. So when I post it, if it's saved, it echoes back the response. Now, if I call get messages, all of a sudden I have one new message up here. If I call the get message again and I change some information, blah blah, message from postman, recipient, we can, we're not gonna mess with the time, and we call get messages again, you will see now we have two messages in our collection. And all of this data lives within the Docker containers. Now, the other APIs we have is update API, which we have a payload here. I just need to change the identifier so that it updates the correct record. And what we're going to do is we're simply going to append -edited. Alex Balyuk, let's say 2. So we send the request, we get a response. If we check the messages, all of a sudden you see that right here is our edited record. We also have the delete method. If we change the ID and send the delete, it tells us message successfully deleted and status code 200. See, status code is 200. If I try to delete it again, it tells me message not found. And the error code is 404 not found. Now, part of the testing, obviously this is very simplistic testing APIs for specific responses. Once these tests are coded, once they verify the data in the payload request, payload response, we're able to take it further and run all of them in sequence in order to generate a test report. Now, this is audit, usually spins up very fast. Okay, here it is. So we can click Run Message API, and you can see that it executed all of them in order, but the delete one failed because delete says bug. We're trying to delete the message which doesn't exist. If we, let's say, add one more message, copy the ID, modify it, save it, and then we rerun it, now all the messages, all the tests should succeed. Because we were not, we didn't prepare the environment for test. We didn't have the data which we tried to delete. So you can see that this is example of automated test because everything got tested with a button click. This can also run in a command line. There's details from Postman on how to execute it from command line. So we're not going to integrate this, but I just want to highlight that these tests in Postman are not wasted and they do contribute to automation testing. But even better idea would be to run automation tests within the code to test the code, to basically do unit test coverage. All right, so from here you can see that we're running our application in a container. We're interacting with our application in a container from our local environment. The next step, this basically tells us that this app is ready to go to be deployed somewhere else, because now we run it locally. We don't have any specific dependencies on operating system, on versions of the software. It's independent because it runs in a container, and we can push it somewhere else. So in the next step, we will push it to GitHub, to a new repository, and then we're gonna configure then we're gonna configure Azure and deploy application there. There are different ways to create a repository. First way is you just go to GitHub. Once you log in, you land on your account, click New, specify a repository name, description, make it private or public, depending what you're trying to do. Public means everybody has access to this. Private means only you have access to this. Configure it, click Create Repository. It should create repository. Now, since Microsoft purchased GitHub, they've been doing a lot of integrations from Azure. They've been doing a lot of integrations from Visual Studio Code, Visual Studio, and other software which Microsoft has. So they have, you can actually initialize Git repository right in Visual Studio Code without any special software, any external software. Also, they have this magic button that says publish to the GitHub, and automatically it specifies the name of the repository to match the directory. You see, this is the directory where the code is. So it says, let's publish it to a private repository or let's publish it to the public. We will choose private. So we're gonna actually, yeah, we will do public repository. So we're gonna publish it as to a public repository. And you can see that it's publishing and creating first commit. Might take a minute or two. And it says successfully published and open in GitHub. So if I open in GitHub, you can see that it is my profile and this is a public repository which just got pushed from my local environment. My README file is here, all the links which I referenced in the, most of the links I referenced in the presentation are here. The code for Web API is located here, including the environments with the connection strings, which this is why it's a bad practice. If I had really real connection strings to real shared database, this would have been really, really bad. InfoSec departments would hate this and you could get in trouble for that. So generally the environment configs are excluded, or at least passwords are excluded from it. But since we're using local environment configs, we don't really care about that. And we will configure, once we configure Azure services, we will not be committing those secrets to the repository. We're gonna configure them through environment variables in the services. So now we have code repository with all of our code. Good practice would be to set up Azure Actions to configure it, to build the application, to test the application constantly when the code is committed. We are going to skip this step and we're going to focus on the cloud on deploying our application. So let's jump to Azure and explore the options there. Right here in the repository, you will find Azure Portal link for free student registration. Registration is free. They give you $100 credit in order to play and learn different Azure services. When you click Activate Now, you will have to fill out the registration process, identify your phone number, and perform student verification. Since I already have the account, I'm not gonna go through that process again. I'm just gonna give you a quick run through the portal. Once you sign in into Azure Portal, that's what it's gonna look like. It doesn't seem like much, but this magic button, create a resource, will bring you to the screen where you can search different services you might be interested in. It's like a marketplace. They actually have a marketplace, and there's a lot of their proprietary as well as commercial third-party offerings for cloud solutions. For example, Elasticsearch is here. It's not native to Azure, but they have integrated with Azure to make it point and click deployment for the different users that want to run Elastic Cloud in Azure. There are blockchain solutions. There's even, I'm surprised to see this. There are lots of computing services, Kubernetes, virtual machines, database solutions, various developer tools, Devops solutions, different integrations, IoT solutions. So there is a ton of stuff, just simply a ton. It's a lot of stuff and it's hard to keep up with all of it. If you click this menu icon, you will see that in favorites, these are actually defaults, some of the favorite defaults. And they list resource groups, app services, functions, SQL databases, and Cosmos DB and virtual machines. Those are probably the most commonly used services. Um, Resource groups allow creating kind of like a not a container, but more of like a tag and associate all of your virtual machines and processes and costs with a specific group. That's what resource group is. It does have certain specifications about what things are and where they run, and every single feature, every single cloud offering has to be linked to a resource group. You know, resource group doesn't do anything on its own. It's just kind of like a linking umbrella on other products which are offered. So what we're going to do is we're going to create an app service in order to run our application. And we need to create Cosmos DB because we are not going to run a Mongo in a container in the cloud. We're going to run um, a Cosmos DB database. So before we start, we're going to create a resource group. Normally, a resource group would specify it would specify specific function or location or department or something that makes sense for our organization to group their resources together. It might be back office work, it might be front end web applications or middle tier um, or resource manager separation to some extent in order to drill down into the costs and understand which groups are more demanding than others or which groups are using certain features and so on. We're just going to create a generic one and put all of our stuff under it. Azure also supports a concept of tagging, and tags, again, they support looking at billing and be able to break down things by specific tags to understand where things are spent. For example, we could tag services like web apps versus APIs versus internal, external, and then run a report in order to understand how much internal stuff costs us, how much external and internal cost us, basically. Once we go to the last step, review and create, you can see that everything got validated and passed. So we just need to click a create button, and the app service gets spun up. Not the app service, sorry. The resource group gets created for us. So now we can move to the next step for creating our dependencies. If you remember our application diagram, we wanted to create a Cosmos DB and a REST API in our first step. And now we have a resource group, so now we're ready to start creating underlying resources. Since application depends on the database, we will create the database first, and then we'll create the app service. So let's go ahead and create a Cosmos DB. We go to Azure Cosmos DB, click Create Resource. We have to specify the resource group. We have to enter account name. That is kind of like a just identifier for it. We have to specify what API or what driver are we going to interface with it. And we're going to select Azure Cosmos DB for Mongo API. This will allow us to use Mongo's driver to interact with it. Next step is location. This indicates where we want to run it. If we run it in West US, it's going to run on the West Coast. Doesn't really help us being here on East Coast. So we want to select US East location, which is data warehouses in Virginia. Then we have to look through the other options flags that are specified. Do we want to run a free tier? Yes. What kind of account type, production or non-production? This will impact the pricing, and this will impact some of the behaviors of all the solutions. We don't care about geographical redundancy because we don't want to run it in, on East Coast and the West Coast and Latin America. We just want to run it in one location for our test app. But for production, depending on application needs, on business use case, this might be important and can really help cut down on the latency. Networking, we can lock it down and only run it on private networks, on internal basically, or public, or all networks. Best practice is probably private networks, but we would have to go into the subnet configuration. So we're gonna skip this for simplicity purposes. We're not gonna drill into the networking. We're just gonna open up access to our Cosmos to all the networks. Backup policy, I don't really care. Encryption, default, tags. As mentioned before, tags are used to help roll up the reporting and billing. So we're just gonna review and create. So within 13 minutes, it should create an account for us. And you can see that it is spinning up the process in the background. It will take some time, but we're able to continue our exploration and we can move on to the next step on configuring the application service. And this process, you can see it's still running here in the background. Once it finishes, we will get a notification. So the next step is to set up an application service, which is basically going to be our REST API. It is our application service. And it's, again, we're not managing servers, we're just deploying our app on some server somewhere in the cloud. We're gonna give it a name. It's a very long name. How are we gonna publish it? Is it gonna be deployed from code or from Docker container? We wanna specify Docker container. Operating system, Linux or Windows. Region, where is it gonna run? So we wanna stick to East region for simplicity purposes. We don't wanna, travel across the United States to hit our application. And we're gonna run it through a Docker container. And in here we have specification on what size of the environment are we gonna run. And if we click it, it's actually going to show us costs associated with it. So let's give it a second. So you can see that if we run a production setup, we're gonna pay $70 a month in order to run it. We can switch to development test environment and we can run this like medium-sized application for $12 a month, or we can run the other application, which is only gig of memory and certain amount of computing time per day, completely free. We're gonna use, this one is a bit slow, honestly. This one is not that bad, so we're gonna select it. I also don't know if you noticed, but while we were exploring it, we got notification that our Cosmos database has been deployed. So Alright, so as you can see, in order to set up the Docker, we do need to select an image from the registry, and we have not set up the registry just yet. So what we have to do is we have to take a step back a little bit and configure our Azure Container Registry. As you can see right here is Container Registry. We can also click Create Resource and find it. And here we have nothing. We have no containers here. We don't have a registry. In order for Azure to deploy a container, we need to save a container here. So first we create a container registry. We specify a resource group. We have to specify the name of it. Again, FAU CEN5035 Azure Container Registry. Okay, we cannot use any ACR demo not very intuitive name, but that's what they would like us to do. We specify the location, we don't care about the availability zones, and we're going to use basic usage. Networking, nothing to specify there. Encryption, nothing to specify there because it only applies to premium services. We're going to review and create it. This will create a container registry, and we will be able to take our existing containers and push them to our container registry as soon as it gets spun up. Probably gonna have to use command line for this, or maybe some built-in features of Visual Studio Code. So you can see that the resource became available. We can now open it up, and you can see that we have repositories. So this is not code repositories, this is container repositories. And here are also access keys for how to log in to the server. So we will have to access, we'll have to push the repository over here. Once we push, the data will become available. So let's try to do this through Visual Studio Code now. All right, so we're back in Visual Studio Code. We've previously built these containers. If we look Docker images, we have quite a few here. Right here is our web API image, which is fairly new. And this is the image which we want to push upstream so that it can be utilized in our build process. Visual Studio Code has a plugin for Docker. Once we switch here, we have container, a list of containers which are available, and we also have registry list. So we can actually connect to the registry right here, and it shows us a subscriptions which we have available. And you can see our FAU subscription is right here, is available, and it has information. So now we just need to figure. All right, so here's the list of our built images right here. We just need to find our image, which is web API from 40 minutes ago. We have to right click it, push it, because we need to push it somewhere, right? It's on we build it locally, we want to upload it. So we have to push it. We're gonna push it to pay-as-you-go subscription to our FAU container registry under the latest tag, enter. And as you can see, because I'm already logged in through my Visual Studio Code, it is pushing the components of the software up. It is uploading them to the cloud. Now, once it uploads, we will be able to go back and continue and finish our setup of Azure App Service. So let's see. Right here's our container registry where we just push the image, and look, right here in the repositories, all of a sudden we have our new image appear. Now this is one way of doing this. This is probably the easiest way. Ideal process would be to have an action set up, and the action would be right here, Azure Container Registry login, container build, and here's Azure Container Registry build. So ideal way would be to configure this config section inside of GitHub Actions, so that the container build is automated with the code repository. This way, the container is created when unit tests pass. When the testing finishes, container gets created and pushed to container registry. We skipped that step of CI CD configuration, and we push the container manually from our development environment. And if we go back to our app service configuration, you will see that here we have a registry, and it doesn't like something. Maybe. All right, so Azure recommends us to go to this specific URL to enable admin user access as per documentation. So here's our URL, and here's admin account configuration. They basically say that we have to go to the portal, go to access keys, and enable admin access. So it should be pretty simple. Enable admin access. So it gave us a username and passwords for our container registry. Let's try refreshing this and see if. All right, so as you can see now, after enabling the admin setting, it allowed us to select the registry. It gives us a drop down of all of our available tags, available images, and it allows us to specify what tag we want to deploy. So we're gonna always deploy the latest version. Let's keep moving. Monitoring. We are not going to enable monitoring. We're not gonna set up tags. We're gonna review and create the application now after it validates. And we're gonna click create. So it's deploying resource. While it's deploying resource, what we need to do is we need to go to our Azure Cosmos database, and we need to extract the connection string. As you can see, the connection string here contains the secrets. It has the username, it has very long, complicated password, and the database path. So we need to copy this because we will have to apply this as our if you remember, we have environment config with this connection string. So we will need to set this connection string in app service so that it connects to the correct database. Okay. I'll just save it here for now, just so I have a copy of it. Let's jump back to our app services. App services, and you can see that we have an app service running. And if we, is it fully running? Yeah, it finished. And if you look over here, we have a URL. If we open this URL, our application responds to us, it talks to us. But I'm pretty sure if we go /messages, it will give us errors because, or it's gonna give us connection error or something along those lines. Because MongoDB doesn't, the application doesn't know where to connect. In order to fix this, we will go to configurations, and this is where we will inject an application setting with the value of our connection string and the key of our environment variable. Click OK, and you will see that it's right here, configured, our connection string. We will save it. What this will do, it will, like, our app didn't return any messages, but now once it recycles, we will be able to see what's happening with it. Also, for debug purposes, if we scroll to the bottom of App Services tab, we'll see log stream. Monitoring logs helps us basically see what the container is talking. So it did have some sort of an error, and then it restarted, and it looks like it is listening and running right now. So what we want to do is, let's just see how quickly it responds, and you'll see that it's responding almost instantly, which is a good sign. And what we will do is we will copy this URL, we will jump back to Postman, we will configure a new environment, Azure App Service, and this is needed just to replace the URL so that we don't have to, so that we can use a variable instead of configuring it over and over again in many different places. So here's our Azure App Service. Now what I can do is I can switch my environment to Azure App Service, and I can interact with it. If I send an API request, I get back a response. Let's see if you see what I'm talking about. You see the host name matches the host name here because we're hitting the same exact API. If I call get messages, I get nothing. If I add few messages, you will see that the data is being added. Number 2, blah, blah, blah. Add something longer. And now if I call get messages here, you will see that I have messages logged. And I think if I call messages here, I see the same exact behavior. So as you can see, we're interacting with our REST API, and we are persisting data to the cloud services. Now what we will also look at is we will look at the Cosmos DB, because Cosmos DB has Data Explorer section where we can look at our collections and our data. And inside of, I guess, the test database is the default, we have messages collection. This is where we are writing data to. And if we click documents, you will see that it loads our documents created at specific date, time, recipient information, message, and we have 1, 2, 3, 4, 5 different entries. And what we will do is we will go ahead and delete one using our API. Successfully deleted. And if I refresh the data here, 1, 2, 3, 4. So you can see we're interacting with our cloud database using our REST API, which all runs in the cloud. And we do not have a single server that we have to log into in order to interact with it, configure it, set up the dependencies on. Everything is completely serverless. Everything is infrastructure, platform as a service. We're using the database as a service. We're using application container hosting as a service, and we don't have to worry about anything special. All right, so that helps us wrap up our configure and deploy to Azure serverless. The next step, we will look at integrating some extra service into this and deploying and redeploying the application using the container. In order to create the next step in our application, in order to create a queue, we have to create a storage account within Azure. So when we go to Azure, we click storage accounts, create. We select our resource group that we want all the information to be linked to. We have to name the queue with the storage account name, demo queue. We're gonna name it as it is. It's gonna be a standard setup with a simple regular storage, public networking. Again, we're not gonna go into the network configuration. We do not need extra versioning, extra sending copies for data protection, so we're not gonna worry about this section. Let's quickly review here. we're gonna use TLS 1.2 configuration. For blob storage, sure, allow public access. The default tier for blob storage is hot. We disable data laking. It's a lot of options, but in most cases, it's just a matter of keeping the defaults unless you have specific use case that requires those extra features. Once things get a little bit refreshed, validated, we will be able to proceed to the next step. The next step is going to be quite simple. There are articles on Azure documentation side about what the queues are. Basically, queue is a place where we can push data to, a message to, and prevent application from waiting on certain heavy processing to complete. So we just push something to the queue, something else can read from the queue and do processing. What we're gonna do is install a package which enables us. We're gonna use a queue client and a connection string to the queue in order to connect to it. So validation passed, we're gonna go ahead and create it. And it created the resource. So now we can navigate to the resource, and we have a lot of different options here. One of the options you can see in storage, there is containers. This is like special storage containers for blobs, for large objects. And separately, we have different sections for queues. So in queues, we can actually create a test queue, for example. So the queues allow us to configure individual queues within the storage account, and we can store a lot of data. There is a certain limitation, I believe it's 2000 messages per second limitation, which is really high for most use cases. In order to interact with the queue, we do need to get an access key. And right here we have a connection string, and this is what we're gonna need to copy into our application in order to integrate the queue. Since we copied the connection string, we can now paste it into our application for development testing purposes. So we configured two variables. One, the connection string itself, and the other one is the queue name, meaning where the data is gonna go. The changes, overall changes are really simple. We've added a new service called Queue.js, which imports data from Azure storage. It does have extra debug information, and we export a function which allows us to send the message into the queue. It's literally one function call that we're adding here. And inside of the server application, when we add a message to the database, before adding it, we're gonna push it into the queue. It's maybe not the ideal situation, maybe not the ideal implementation or sequence of events, but again, this is just for demonstration purposes of how easy it is to integrate these. Once we have this added, whenever we run the next, we're going to spin up node.mon. It will start up our development application on port 3001. Switching to Postman and switching to localhost development environment, we have some messages added. When we add a message, there will be an extra console debug line because it is written here. When a message is getting queued, we are printing to the output, standard output, indicating that the message was added. And the message which is added is a JSON string of the message itself, of the data itself. So let's take a look. We're gonna send the data, send, and boom, right here, the whole record is getting printed out. The record after it has been saved is getting printed out. So we have the ID, and everything. And that information, I'm gonna send a few more messages. So we have 1, 2, 3, 4 messages which have been saved to the queue in addition to being saved to the database. Now, when we jump to our Azure portal, when we go to the queue area, you will see that right here we have this FAU CEN demo queue. When we open it, you will see the messages themselves. So as you can see, our application now integrates with a queue, pushes data into it, and now it's a matter of just implementing a separate service that dequeues information and processes and does something separate with it. Basically an Azure function, now the message is in a queue. Now Azure function has to take the message out and send an email or send a push notification, do anything resource intensive. And what it's gonna do is just gonna call a dequeue message command, pop a message, call the next one, pop it, call the next one, pop it. And then the queue is going to be basically filling up and clearing on demand. It's as simple as that. So now, since we made those changes, we also wanted to add application level monitoring. So let's quickly go through application insight configuration and then tie it all together. Just like before, to create app insights, we click create button. We specify the resource group we're gonna use. We give it a name. We specify the region where it runs. We want to have all the regions match. And we're gonna create a classic resource mode so we don't have to create some other dependencies for the new features which Azure published. This will spin up app insights and we will copy the API key into our application. Just like all other Azure features, there is extensive documentation on how to integrate the monitoring on the application. You can see that we simply have to run dependency installation, initialize it, and provide the API key on the start. And this software is smart enough to integrate into Express events and monitor the URLs, monitor the response times, and so on. We also have ability to do custom telemetry, which we're not gonna look into. I think the generic telemetry is more than exciting for this use case. So as you can see, we have environment which got set up, not environment, but app insights that got set up. And in here we have application map, live metric, failures, performance, and some other features. At the moment, all of this data is empty. We cannot look at it. We cannot see how our application is doing, if it's healthy, unhealthy. But we do have this instrumentation key, and this is what we need. And when we jump back to the application, we just want to save it in a config so that we can at least interact with our stuff. Actually, wasn't a good idea to commit some of that stuff to the public repo, but we'll clean it up after. We'll destroy all the resources after. And in the code, if you want to see, really all we had to do was to install a dependency of App Insights, and we had to initialize our application startup. The rest happens automatically. Yeah, I'll keep it there. So I'm gonna commit the App Insights changes and push them up to the repository. And what I'm gonna do here is I'm gonna run the Docker compose build command. Okay, docker compose the build, docker compose up. And this is going to rebuild the container with the new features. Now, I'm not gonna test the container locally. I tested it earlier. So what I'm gonna do is I'm simply gonna find my container here in the list, and I'm gonna push it up again. I'm gonna push it to our container registry, to the latest tag. So this will replace the container which was there. Again, normally we want to version them and keep the different old versions, but I'm just pushing it to the latest one. And if we go back to our app services, these are supposed to redeploy automatically because we do have this deployment center running. All right, as I found, I didn't have the continuous deployment enabled, so that's why the application is not getting auto-deployed. This setting needs to be toggled. And technically, after saving it, it should detect a change of a container. So you can see that it is downloading a new container now, because it's 20 minutes right now. So let's see, if we jump to the logs, we should see our application being refreshed. Okay, so looks like our container is erroring because we committed your key value there rather than committing an environment, a proper variable. So as you can see, our code has a bug over here and we do need to fix it. Okay, so this is a bug fix. After this, I have to rebuild the container. After rebuild, we have to push it up. And there is one more thing we need to do. These connection strings do not exist on the container configuration. So while the container is being deployed, I will jump to the configurations and I need to apply my new settings, which are, these were used for dev, but I need to have these in prod as well. And the app inside API key as well, because we're not deploying this environment configs into the Docker container. Without applying these here, container has no knowledge of those endpoints and it can create application misconfigurations or maybe even errors. Okay, let's see. What does our deployment center tell us? So you see it says 22 minutes, meaning it just pulled the container, and I think it is coming up. Yep, our application is up and it's talking to us. So what we can do is we can jump to Postman. We can switch our endpoint to Azure and just try to interact with it. We can try adding a message. We can running an update message, which fails because we didn't give it the correct record ID. We try to update the record which doesn't exist. And if we run delete on a record which doesn't exist, this will generate I deliberately generated about 10 failed requests, and then I'm going to run a successful one. And the reason I'm submitting a bunch of requests is just to give our application insights a little bit more information on application behavior. Okay, so while it takes a little bit of time for the data to process, but what I'm going to show you is that if we look at, again, the data explorer within Mongo, within App Services, sorry, when we look at data within Cosmos DB, we will see that we have, a couple dozen records probably, which were added over here. Also, we've added a queue, and if we look at our storage account, every time we add a record to the queue, it was adding another queue item for some sort of post-processing. So you can see there is a bunch of the entries over here. Now, hopefully, App Insights processed the data which it was capturing, that when we were interacting with application, we registered the telemetry collection. And now you can see that it's aware of our application map. So it knows that we have one web app which talks to a MongoDB, and it talks, there are some administrative features, I guess, which are being invoked, the latency associated with it. We can look at the failure analysis and see what transactions are failing. We can see what, well, we don't have exceptions here, so it's not painting a good picture for us. And it's probably still processing some of the information in order to visualize all of our requests. But you can see that it's already capturing some information on internal response times specific to MongoDB within our framework, how long the find takes, how long the delete takes. Let's see. Okay, boom, right here, it refreshed. Now you can see that, for example, the get messages was invoked 9 times, the post to messages was invoked 7 times, deletes on specific actions were invoked a number of times. We can see response times. We can drill into the dependencies on those and see where application slowness might be. In terms of application failures, if you remember, I deliberately tried to submit deletes to for a message that doesn't exist, and as you can see, it's captured here, and we have information on it. If application would have had an exception, a hard exception, it would have been captured here. And that's, a quick overview of some key features. So with very easy few implementations, we now have application telemetry. And if you look at, version control, building process, the testing process, deployment process, automation testing process, which, this is a very light version of it, but in theory, we're automatically testing API responses by running a suite. Deploying application to production, we did not utilize the CI/CD for this, which would have been the right thing to do, but we are pushing it to a container registry and deploying it, and then we have measurable data which we validate in the containers using, not in containers, we validate it in App Insights, and we can extract detailed information on different services that we have. We can see their distributions and so on. So hopefully you found this live demo helpful, and it helps you understand some cool features of the cloud, the difference between the solutions, and this very light demo explaining end-to-end implementation and redeployment. All right. Well, thank you very much, and good luck.